Welcome to Breaking the Wall of Terrestrial Seismicity. We will be talking about gravitational waves, the final prediction of Einstein's theory of general relativity. These waves were detected in 2015 for the first time, giving us a new window on the universe. And here's how. So here you see two black holes revolving around each other, merging into one, sending out a pulse of gravitational waves. This pulse, once it arrives on Earth, looks like this, and is very tiny, as you can see here. It is even smaller than a proton. So the effect that you see there on Earth is vastly exaggerated. Because of this wobbling of the Earth, we really need a gravitational wave detector, as you can see there. This is a kilometer scale laser setup, and it will convert this stretching and squeezing into these pulses of light. Now, these pulses of light you see there in the green trace in the graph below. This was awarded the Nobel Prize in Physics in 2017. And this signal, you can see it's a fraction of a second long. So this multiple oscillations per second really means it's a high frequency signal. So if you want to measure low frequency signals and study, for example, supermassive black holes, you need to do something else, because on Earth, we can only shield against the high frequency part of the Earth's motion. And we do that by suspending the mirrors, as you can see here and here in the photograph. And the main motion we cannot shield against is the oceanic activity. So these are the waves pounding on the shore. So where do we go? We go to the moon. So on the moon, we can deploy an update of a sensor that I developed during my PhD. We make it slightly more sensitive and use the wobbling of the moon, just like you saw in the movie, to now deploy an array of these sensors and directly detect the motion of the moon, and thus detect low frequency gravitational waves. As we can see here, so here you see on the right, the best we can do on Earth. And if we want to break this seismic wall that we have here on Earth, we now have our proposal for the moon. And this is very nice if you want to measure these low frequency gravitational waves, but we can also prospect for lunar mining, find ice at the South Pole for a lunar base, and do lunar geophysics. So why wait?